Hey, welcome back Finxters. In the previous video we learned how to deal with the missing values in our data set. Now in this video we are going to learn how to encode the categorical data. So what is categorical data? If you remember that the data which is not in the form of numbers is known as categorical data. That is, the non-numeric values in our data set represent the categorical data. Now in our example, we have couple of columns, country and purchased. These columns have non-numeric values. So these columns have categorical data. Now the question is, why do we need to encode our categorical data? You must remember all inputs and output variables must be numeric in machine learning models. This is because they are based on mathematical equations. That is, machine learning models understand the language of numbers or mathematical equations. Therefore, if the data contains categorical data, it must be encoded to numbers. In other words, most machine learning algorithms cannot work with categorical variables directly. They need to be converted to numbers. Now, even if we find a way to directly work with the categorical variables without converting them to numbers, our model shall get biased towards the language we used. For example, in an animal classification task, if the labels are dog, cat, rat, etc., then using such a labeling method would train our model to predict labels only in English. This would put a linguistic restriction upon the possible applications of the model. That means our model will be biased towards the English language. Now, in order to overcome this issue, we need to encode the categorical variable values and convert them into numbers. Now, one of the most frequently used encoding techniques is known as one-hot encoding. One-hot encoding takes a column that has categorical data and then splits the column into multiple columns. Now, depending on which column has what value, they are replaced by ones and zeros. So we have the country column, which has the categorical data. When we implement the one-hot encoding, the country column will get splitted into 3 columns in our case. This is because we have 3 countries in this category, that is Germany, Japan and India. Now for the rows with the first column value as Germany, the Germany column will be split into 3 columns such that the first column will have 1 and the other 2 columns will have zeros. Similarly, for rows that have the first column value as India, the column or the second column will have 1 and the other 2 columns will have zeros. Quite confusing, isn't it? Because it is difficult to visualize from what I'm saying. So let's try and have a look and break this down, or the country column, let's split it down and see how the one-hot encoding works. So now let's have a look at what we have on the screen. If you see, the first row has Germany in the country column. Now the country column gets splitted into 3 different columns: Germany, India and Japan. Since the first row has Germany in the country column, therefore when the country column gets splitted, the column which is represented by Germany has 1 in the first case. Now in the second case, the country is Japan. So when the country column gets splitted, the second row has 1 in the column which is represented by Japan. Similarly, the third row, which has India in the country column, has the value 1 in the column represented by India. So I hope now you can visualize and compare the two data sets, though both of them are the same, but this data set is not encoded, while this data set has been encoded using one-hot encoding. Let us try and have a look at how we can actually implement this in our code. So without further delay, let us move on to our coding screen. In order to implement one-hot encoding, we need the help of a couple of classes present in the scikit-learn library. These classes are the one-hot encoder class, and the second class is the column transformer class. So let us quickly import these classes from scikit-learn, and then we have the preprocessing module from which we want to import the one-hot encoder class. Now let us import the column transformer class. So from scikit-learn dot, and from the compose module we want to import the column transformer class. So as you can see that the column transformer class is a part of the compose module. Okay, let's create the object for the column transformer class. So I'll name it CT equals column transformer. Now we have created the object CT for the column transformer class. Now inside this object we need to pass couple of parameters. The first parameter goes by the name transformers. Now within this parameter we will have to provide three inputs. First we have to specify the kind of transformation that we are doing, which is encoding. Second is what kind of encoding we are doing, which is one-hot encoding. And finally the third input, which is indexes of the columns which we are trying to encode. So in order to do that we will need the help of square brackets, and within it we would need open and closed parenthesis. Now this is actually a tuple within which we are going to provide the three inputs. So as we said, let us enter the kind of transformation we are doing, which is encoder, then comma, and now let's specify the kind of encoding that we are trying to do, which is one-hot encoding. So I have to specify the name of the one-hot encoder class along with open and closed parenthesis. And finally, we have to specify the columns upon which we want to perform the transformation. So the column that we are trying to encode is the country column, which will have the index 0. So all we have to do is provide open and closed square brackets and within it 0, which is the index of the column upon which we are applying the one-hot encoder. That is it for the transformers parameter. Now we have the second parameter, which is known as remainder. This parameter will allow us to specify the columns upon which we do not want to apply the transformation. That is the columns which we do not want to encode. So since country is the only column upon which we are applying one-hot encoding as of now, so we would want to have age, salary and purchase specified in the remainder parameter. Now the simplest way of doing that is to say pass through. Pass through has to be within quotes. And now let's close the parenthesis. Now we have to connect this CT object to the matrix of features X. So in order to do that, what we did previously was use the fit function and then we applied the transform function. However, in this case we do not have to do that because the column transformer class provides us with a method known as fit transform, which performs the task of both the functions fit and transform together. So in order to do that, let's say our matrix of features X equals ct dot fit transform, and within it we have to pass X or the matrix of features. So what we did was we used the fit transform method and applied it on the matrix of features so that the fit transform method can apply the changes on the country column, and then we applied these changes to our matrix of features so that the changes are reflected on our data frame. Now there's one more thing that we need to do. This is because the fit transform method does not return us an array, and it is absolutely necessary for our matrix of features to be in the form of an array. So in order to convert this, or in order to typecast this to an array, we need the help of the NumPy library. Okay, so let's do that. In order to do that, we'll say np.array. So this is the array function of the NumPy library, which will help us to convert this into a NumPy array. And that's all. We have successfully converted the country column, or one hot encoded the country column. So before proceeding, let's check if this works for us. So let's print x. Now let's execute our code. And there we go. As you can see, we have successfully splitted the country column into 3 different columns. And now let's cross check. The first one is 1 0 0, second one is 0 0 1, and the third is 0 1 0. So let's check. The first one is 1 0 0, second one is 0 0 1, and 0 1 0 is the third one. So indeed, we have successfully splitted our country column, and then one hot encoded it in order to convert it into numerical values. Now we also have the purchased column, and this column only has couple of values, yes and no. So it would not be very sensible to convert or one hot encode this column and break it down into 3 different columns again. Instead, what we can do is to use some technique and say that no should be represented by 1, while yes will be represented by 0. So by doing that, each row which has yes will have 1, while each row which has no will have 0. And this technique of encoding is known as label encoding. So let's have a look at the code and how we can apply label encoding. In order to apply label encoding, we need to import a certain class from the scikit-learn library. So we say scikit-learn dot preprocessing import label encoder. So as you can see, label encoder is also a part of the preprocessing module of the scikit-learn library. Now applying the label encoding technique is quite easy. All we need to do is create an object of the label encoder class. So I'll call it LE, and then I'll create the object. And thankfully this time we don't have to pass any argument within the object. And now all we need to do is to connect this to our dependent variable. So if you remember, the purchased column was our dependent variable vector, which is represented by y in our program. So I'll say y equals le dot, and then again use the fit transform method, and within it I'll pass y. So that's how simple it is. And now let's use the print statement to check if we applied the label encoding properly. So let's execute our code once again, and there we go. We indeed have converted the yes and no values into 1 and 0, that is numeric values. So let's cross check this. We have 1 0 1 0, and we have yes, which should be 1, then no 0, then yes, which is 1, and no, which is again 0. So that's it. We have successfully encoded the country as well as the purchased columns. So that brings us to the end of this video, and congratulations, you have another tool in your arsenal using which you can successfully encode the categorical data in a given data set. So please stay tuned for the next video, where we are going to learn how we can split our data set into the training set and the test set.